The next question is, 2 point charges plus q and minus q are placed at the vertices B and C of an equilateral triangle ABC of side A as shown in the figure. Obtain the expression for the first question, the magnitude, and the second question, the direction of the resultant electric field at the vertex A due to these two charges. This question was there in CBSE compartment examination. So what we have to do is, on the diagram given, you have to draw the direction of electric field due to plus q. That I marked, that is away because it is positive charge. Next we have to mark the direction of electric field due to minus q. That will be from A to C because that is a negative charge. And the resultant you can draw between these two, EAB and EAC. Okay. Now complete the diagram and draw the angle made by the resultant with AC. That also mark, and you can mark that one is alpha. Okay, then the first part we are going to do now, that is find the magnitude of the resultant vector. So you remember one equation for magnitude of the resultant? There was one equation when you studied this parallelogram law of vector addition. Equation was something like this one, square root of a square plus b square plus 2ab cos theta. Here a and b are the two vectors, so we will find first that two resultant vectors. Okay. So the first thing is we are going to find the magnitude of EAB, that is due to that positive plus q. So equation will be 1 by 4 pi epsilon 0 q by a square. Correct? That is actually equal to the letter E, we can say, representing electric field. Next we want to draw the magnitude of EAC, that is the electric field due to that minus 2q. Because of we are writing the magnitude, that will be equal to 1 by 4 pi epsilon 0. We will not write minus 2q, okay? We will write only 2q divided by a square. And if you identify the equation E from this equation, this part, you can see that it look like a 2 times the previous equation, or 2 times 1 by 4 pi epsilon 0 q by a square. So this part is actually E. So you can write this is equal to 2E now. Okay, so EAC will be equal to 2E. Now what we are going to do next is we are going to write the resultant equation. So the equation what I said you before, that is E net, we can say here. Resultant E net is equal to square root of, instead of that a square plus b square plus 2ab cos theta, we are going to write the here first vector here is E. So as the equation I am writing first. Okay, see the equation first. Okay, here A is E and B is 2E. So we can write like this one, E square plus then 2E whole square, because B is 2E here, plus 2 into A here is A2. So 2 into E into 2E into angle between those two, angle between EAB and EAC is 60 plus 60. That is, if you refer the diagram, you will get that one easily, cos 120. Okay, and you have to recall the value of cos 120. See here the diagram first to understand from where I got that 120. It is an equilateral triangle, right? So each base will be equal to 60 and 60. And upper side you can mark, actually one is the corresponding angle 60 is there, and other one is the alternate interior angle. In both ways you can do it. Okay, so here it is E square plus 2E square, we can do squaring now. So 4E square plus the other side 2 into 2, that is 4, and E into E, that is E square, and cos 120. What is cos 120? Anybody remember? So cos 120 is minus 1 by 2. Okay, now we will cancel that minus 1 by 2, that is 2, and that 4. So what we got now? Altogether E square plus 4E square is equal to 5E square. Okay, there's a minus. Okay, so that minus appear here, minus 2E square. So 5 minus 2 actually, so is equal to square root of 3E square. And we will take that E square outside now, because square root of E square will be equal to E only. So E and square root 3. the matter stopped here. You can substitute the value of E now. So E value of E is equal to, we wrote before, 1 by 4 pi epsilon 0 q by a square, correct, into that root 3. So the first part we answered. Now the magnitude part we answered. Okay, now we come to the direction part. Regarding the direction, again you want to recall the equation what you learned along with the parallelogram law of vector addition. There was magnitude of resultant and direction of resultant. Two part was there. So the direction equation is tan alpha is equal to tan theta, whatever it is, equal to EAB sin theta. Actually that sin theta here is sin 120 divided by EAC plus EAB cos 120 will come, because cos theta is actual equation. So we have to substitute the values of sin 120, that is E into root 3 by 2 divided by EAC, that is 2E, we prepared before, plus EAB is equal to E. So E into cos 120 before we mentioned minus 1 by 2. Now start working. It is easy actually, because the simple mathematics now. So numerator will be E root 3 by 2, denominator 2E, plus, remember there is a board mass issue, okay, E into minus 1 by 2 will come first. So minus E by 2. Then do the LCM work on the denominator. Numerator write as it is, and denominator you can do the LCM work. So 2 into 2E will come, right? Because basically 2E we will consider as divided by 1. So 2 into 2E minus 1 into E divided by the denominator multiplication. So 1 into 2. So the numerator we will copy again as it is, E root 3 by 2. And denominator 2 into 2 is for E, and minus E divided by 2. Then the answer is E root 3 by 2 divided by 3E by 2, right? Then do the reciprocal multiplication. So during reciprocal multiplication you can see that there is a possibility of cancelling many terms. So you can start cancelling now. 2 and 2 cancel, and E and E cancel. What left now is root 3 by the denominator 3 we will write root 3 into root 3. So cancelling root 3 and root 3, finally we can write is equal to 1 by root 3. Actually we started from tan alpha. You remember tan alpha is equal to 1 by root 3. So we will do alpha is equal to tan inverse 1 by root 3. So very familiar, yeah, because the two values tan 30 and tan 60 used frequently in Greaton. So here tan inverse of 1 by root 3 is equal to 30 degree. So the direction of the resultant is 30 degree. Okay students, thank you, have a nice day.